This is Algebra 2, Lesson 4.2, Simplifying Radicals. So we probably have experience with a square root. A square root is a type of radical where we were looking for two things that can simplify out. So what I mean is when we have the square root of a product of two like things, that would be equal to just that thing. We can also talk about cube roots. That's when we have the product of 3, which would give us just a single, or a fourth root, which would have 4, which would give us just a single. So the square root's kind of unique because it doesn't put a number out there, but the square root is looking for 2. But whatever number you have as your root, if you have that many being multiplied on the inside, it'll come out as just a single. And we don't have to have just the same thing in there. We can have products of different things in there. So that's where our product property would come in. If we have a product under there, we can also split that into the roots of the two separate pieces of the product. Okay, so that's our rules that are going to help let us simplify some radicals. Let's try some examples. Example A, simplify the radical expression. Use a calculator to check your answer. Okay, so I'm doing the square root of 20. To simplify that, I'm going to break it down into some factors. So I'm going to do what times what equals 20, and there's more than one right answer here. I'm going to go with 2 times 10. You could do 5 times 4. Whatever way you do it, it's going to break down to kind of be the same thing in the end. So I'm going to stop at 2 because that's prime, but I'm going to break down my 10 as well because I know 10 I can get with 2 times 5. And again, those are prime, so I'm going to stop there. We're going to keep breaking down our numbers until we reach prime values. And then as soon as we find a pair, and it is a pair specifically in this question because we're looking at a square root, we're going to know that we can pull out a pair, and whatever doesn't have a pair gets left behind. So the square root of 20 would simplify to 2, and that's a 2 in the front because a pair of 2's comes out, and then root 5 because there is a 5 left over. Okay, now at the space down here I got to check my answer, and I'm going to open up my calculator. I'm going to type in the square root of 20 and see the decimal, and then I'm going to type in 2 root 5 to check the decimal to make sure I have the same decimal, then I know I have the right answer. Okay, so on this calculator here, let's go the square root of 20, and that looks like 4.47. Then I'll go 2 times the square root of 5, and that looks like 4.47. So I checked my answer. They're both approximately equal to 4.47. Let's try another one. The square root of 252. So 20, to me, that was super obvious. 252, I don't really know what the factors are, but I know it's even, so 2 should work, okay? So if you're not really sure about what times what gives you the number, you can always start dividing by common primes and just seeing what comes out, right? So I divided it by 2, and that gave me 126. Now again, I don't know my exact factors of 126. It's even again, so I know 2 should work, but I'm going to try 4 just to see what happens. So I'm going to divide it by 4. And that one gave me a decimal, so that's no good. We do need to have whole numbers when we check for our factor pairs. So I know that 4 is no good. Just wanted to see what happened, but now I know 2 should work again because it's even, okay? So 126 divides by 2 to give me 63. And I know 63 won't divide by 2. It is an odd number, but it probably divides by 3 because it ends in a 3. So we'll check that one. 63 divided by 3. That looks good. 21. And I'm kind of running out of space here, but I'm going to keep going. And I know 21. 21 is 3 times 7. And again, if you're not sure, keep dividing by common primes 2, 3, 5, 7, 11 until you reach all prime numbers. Okay, so now when I have all these broken down, I'm not considering them anymore, but I'm looking at all the primes that I broke that into, and I'm looking for pairs. And again, it's pairs because square roots, I'm looking for pairs. So I have a pair of 2's, that will come out. I have a pair of 3's, that will come out, and I have a 7 left over. Singles stay inside. We're going to multiply these together to get a 6 root 7, and that will be my final answer. So I'm going to check it again on the calculator. I'm going to do the square root of 252, and that comes out to 15.8-ish. 6 root 7 also comes out to 15.8-ish, so I know that my answer checks. I'm going to say 0.9 because I know there was a 7 after that 8. Okay, I got another example, the cube root of 2,160. So notice that this is a cube root. That means we're looking for groups of 3 to come out, not groups of 2 to come out. I see a number ending in a 0. I know that if it ends in a 0, it has to divide by 10, and that will leave me with 216. Okay, 216, that could divide by a 6. Let's see if it works. Look at that, 6 and 36. Ooh, and 36 is a nice number. So 216 splits into 6 and 36. 36 splits into 6 and 6. And I'm going to stop there. I know 6 isn't prime, but I have a 3 of a kind on a cube root. I know that'll come out. So I'm going to go ahead and circle my 3 of a kind. Again, 3 of a kind because of the cube root will come out. And then what's left behind, actually what I should do is I should split this 2 and 5 up for this 10. But again, those are singles that stay behind. Will be a 2 and a 5, but then they just go right back together to 6 root 10 being my final answer. Okay. Checking my answer on this one is a little more difficult on this calculator. I have to go into math and find my cube root. But the cube root of 2160 comes out to the approximate decimal of 12.9. And then I had 6 cube root 10 is the same decimal approximation. Okay, so let's try a couple of simplifications that include some variables. Now we're kind of doing the same thing. We're looking for groups of 2 on our square roots, groups of 3 on our cube roots, groups of 5, right? Problem C has a 5th root to be able to pull out. So starting with our 125. 125 splits into 5 and 25. I'm going to show you how I did that. I just did it in my head, but when we divide by 5, I know it's got to be a 5 because it ends in a 5. And hopefully we know 25 is 5 times 5. So we are looking for groups of 2 because we have that invisible 2 in our square root. So I have a group of 2 that I can pull out, but there is a single 5 left over. Okay? And then I'm also going to break down my A3. I'm going to break that down into A. So again, we're looking for a group of 2 to come out and a single left over. So when a group of 2 comes out, it's a single 5. When a pair of A's comes out, it's a single A. And then for my leftovers, I have a 5 left over and I have an A left over. So this isn't really something we can check on the calculator because we don't have a way to get a decimal approximation with a variable. So I'm going to move on to letter B. We're going to break down our 98. I know that is 2 and 49. If you're not good with your factors, remember try dividing. 98 divided by 2, 98 divided by 3, 98 divided by 5. Divide by your common prime numbers. And I know 49 is 7 and 7. So I have all my primes now. I'm going to break my M4, 1, 2, 3, 4. I'm going to break my N3, 1, 2, 3. We're looking for pairs, but be mindful that there's already a 2 on the outside. Okay, so I'm going to start with that 2 on the outside. I see a pair of 7s. I see a pair of M's. I see a pair of M's and a pair of N's. Okay, that's all my pairs. Then I'm going to look at what I have left over. I have a 2 left over and I have an N left over. Once we have everything pulled out, we're going to multiply everything together for our final answer. So 2 times 7 gives me 14. M times m gives me m squared. N is just n. Root 2n is my final answer. Last one, we are looking for groups of 5. Okay, so 32 is 2 times 16. 16 is 4 times 4. 4 is 2 times 2. 4 is 2 times 2. X 12. Do I need to write them all out? Sure, why not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y5, 1, 2, 3, 4, 5. Maybe make them curvy so they look more Y-like. And Z4, 1, 2, 3, 4. We're looking for groups of 5. We got 1, 2, 3, 4, 5 twos. That's A2 on the outside. We have 1, 2, 3, 4, 5 X's. That's an X. 1, 2, 3, 4, 5 X's. That's an X. 1, 2, 3, 4, 5 Y's. That's a Y. And I can't make any more groups of like factors. So on the inside, I have no numbers left over. I have an X and an X right here, XX. And I have 4 Z's. 1, 2, 3, 4. Then we're going to put everything back together. 2 stays 2. XX turns into X squared. Y stays Y. Inside my 5th root, I have 2 X's, which becomes X squared, and the product of 4 Z's, which goes back to Z4. Hopefully that was very exciting. Let's go crazy with a couple more. Example C. Multiply the radical expressions. Letter A, radical 5 times radical 10. What we're going to do is multiply our radicands together. 5 times 10 becomes 50. And then we're going to break him down. I guess we can go right back to 5 and 10. 5 and 2. I got my pair of 5s. He comes out. 2 left over. 1 5 comes out, 2 left over. Final answer. Let's break these guys up the same way before we even put them together. So we have 5, 3, 5, 2, and I'm going to write out my 2 ends and my 1, 2, 3, 4 ends, right? 4 and 2. So my pair of 5s right here comes out as A5. I have 1 pair of 2s. 2 pair of 2s, 3, 1, 2, 3. I have a 3 and a 2 left over. Okay, so that's going to be a 5, an n cubed, root 6. 3 times 2 is 6. And last one, we're looking for groups of 4. We're going to break it all down. We have 1, 2, 3 X's, 1, 2, 3, 4, 5, 6 Y's, 1 X, 1, 2, 3 Y's. And again, groups of 4 come out. So I have 1, 2, 3, 4 X's. Let's go like this. 1, 2, 3, 4 Y's. 1, 2, 3, 4 Y's. And 1 Y left over. Simplifying that is X, Y squared. Make sure that this is obvious, that this is the 4th root here. Some people like to put this in parentheses, so we're not like looking at it like 24 on accident, right? The 2 and the 4 don't get smudged together with a Y left over. So with or without the parentheses, just to differentiate the square on the Y versus the 4th root on the Y. Final answer. Hopefully that wasn't too much. Good luck on the exercises, and please let me know if you have any questions.